Physicists keep asking, why don't we see quantum effects in the macroscopic world? The real answer is simple. Because quantum mechanics was never meant to describe high-complexity systems in the first place. But reductionists keep pretending otherwise. If you can only solve the Schrödinger equation exactly for hydrogen, but not for a molecule, not for a cell, not for a cat, and not for anything remotely complex. Why would anyone believe that the classical world must somehow come out of quantum mechanics? That's not science. That's wishful metaphysics wearing a lab coat. So they invent stories. Quantum Darwinism, decoherence, pointer states, each one trying to rescue the fantasy that all of reality is secretly quantum. Meanwhile, they silently ignore algorithmic information theory, which proved decades ago that increasing complexity generates irreducible structure that cannot be derived from simpler rules. Classicality doesn't need an explanation from quantum mechanics. It emerges when complexity crosses a threshold where quantum descriptions become algorithmically irreducible, operationally useless, and conceptually meaningless. At that point, the system isn't quantum behaving classically. It's simply not quantum anymore. Reductionists hate this idea because it shatters their dream of a single universal theory. But reality isn't a toy model. Classical identity, space, time, stability, measurement, all of these are emergent, not derivable from the wave function. Their mistake is assuming the map must describe the territory at all scales. It doesn't. The truth is simple and unforgiving. Complexity creates new rules, new properties, new realities. And no amount of reductionist nostalgia will compress that away. Quantum mechanics is brilliant, but it is not the blueprint of the universe. It is just the blueprint of simple systems. So the next time someone asks, why don't we see quantum effects in the macroscopic world? You can answer. Because the macroscopic world is a different level of reality, a level where reductionism breaks and complexity takes over.